Welcome to the case study Traffic Matrix Design, where this tool of the open source application Net2Plan will be explained. First, given a network topology and traffic demands associated with the network, each of these traffic demands represents an offered end-to-end traffic flow to the network. In Net2Plan, demands are considered unicast, that is, they have only one ingress node and one egress node. In addition, self-demands are not allowed. A simplified approach to model the offered traffic between nodes is the so-called traffic matrix. A traffic matrix is a n by n matrix where n is the number of nodes in the network, in which each pair ij represents the average traffic from node I to node j. We can see an example of a traffic matrix in this slide, where for example the offered traffic from node 0, this is the row, to node 0, to node 1, this is the column, to node 1 is 9 lengths. Net2Plan allows to generate the traffic matrix using different methods that we are going to see now. After opening Net2Plan, click on Tools and then click on Traffic Matrix Design. This window is divided into several sections. The upper part of the left window gives access to a set of general traffic generation models. Below, in this part, user can generate matrices using one particular method, the population distance traffic model. The right panel shows the traffic matrices generated and permits saving as N2P file, loading, resizing matrices, manually insertion, and some other simple modifications in the buttons above the matrices. In the lower right side, the traffic normalization panel permits applying a normalization method to one or all of the traffic matrices in the upper panel. The panel below permits selecting a method for producing a set of traffic matrices from a seminal one in different forms. Now we focus on right section. We are going to generate one matrix manually. The first step is click on resize this button that allows to introduce the desired number of nodes, for example 4, and click OK. After this, matrix can be manually filled. Its traffic can be manually inserted by clicking on them and typing the new value. As self-demands are not allowed, values of the main diagonal will remain 0. So we fill matrix here. Appear the total traffic by column and the total traffic by row and the total traffic in this matrix. Now the traffic matrix of the example slide has been created. This matrix. Then click on save this button, allows store this matrix. Select a directory and introduce a name. Click on save. For example, traffic matrix sample, and click on save. Users can make more than one matrix simultaneously, repeating this operation by using resize all and save all buttons. Buttons make symmetric this and make symmetric all produce symmetric matrices. The traffic between two nodes becomes the average between the traffic in both directions. If we click on make symmetric this example will be symmetric. The pattern SUMAll adds a new traffic matrix to the panel, which is the sum of all the traffic matrices shown. All of them must have the same number of nodes. For example, SUMAll generate a new traffic, but in this case there is only one matrix, so the new matrix is the same. The patterns multiply this and multiply all points, multiplying all the coordinates of these all matrices by a constant factor. For example, if we click on multiply all and introduce a multiplicative factor, for example 2, and click OK, this matrix has been multiplied by this factor. The buttons reset this and reset all sets zeros in all the coordinates of uptick all matrices. For example, click on reset this button and this matrix is reset. The button clear all eliminates all the matrices in the panel. And finally, by clicking load button allows open another matrix file. For example, if we select this traffic matrix and click on open, appear this traffic matrix in the panel. Now we are going to generate some matrices. 1 using a constant model, 3 using a uniform 0-10 model, 4 using a 50% uniform 0-10 model and 50% uniform 0-100 model, 1 using the gravity model, and 5 using the population distance traffic model. To do this, we focus on the left section of traffic matrix design window. Well, to generate a matrix using a constant model, click on this drop-down list and select the constant pattern. This traffic model generates an n by n traffic matrix where n is the number of nodes with a given constant value in all its coordinates. Then click on apply this pattern and select the number of nodes. In this case 5 nodes and the constant value, for example 3 Erlangs. Click OK and click on yes to clear the previous matrices. Here is the traffic matrix filled with a constant value. Again, by clicking save this button, this matrix can be stored. Now, to generate 3 matrices using an uniform 0-10 model, repeat the operation. Select in the drop-down list the uniform 0-10 pattern. This traffic model generates an n by n traffic matrix with random values in the range 0-10. So then click on apply batch button, introduce the number of nodes, for example 4 nodes, and number of matrices 3, and this checkbox enable make symmetric traffics. Click on OK, click on yes, and now we can see these matrices in the right section. In this case, by clicking save all button, matrices can be stored with the same name and an identifier number each one. For example, introduce a name, uniform 0-10 traffic matrices, and click on save. If we click on the load button, we can see these 3 matrices. Now we are going to generate 4 matrices automatically using another model. Repeat this operation. Now we select the fourth model that generates an n by n traffic matrix with 50% of its entries with random values in the range 0-100 and the rest of the entries with random values in the range 0-10. Click on Apply Patch button, introduce the number of nodes, 5 introduce the number of matrices, 4 click on OK, click on Yes, and then we can see these matrices in the right section again. To store them, click on Save All button and select a directory. OK, now gravity model will be used to create one matrix, so repeat the operation. But before, we are going to explain this traffic model. This traffic model generates an n by n traffic matrix according to the gravity model. The user should provide for each node n its total traffic generated and received. Naturally, the sum of all the traffic generated by all the nodes should be equal to the sum of the traffic received by all the nodes. We denote it as h. From this information, the coordinate ij of the traffic matrix is given by this expression, and then the traffic from node I to node j is proportional to the total traffic produced at I and proportional to the total traffic received at j. So select the gravity model in the drop-down list, click on Apply this button, introduce the number of nodes, for example 5, click OK, click on Yes, and it appears this pop-up to introduce the total ingress traffic per node and the total egress traffic per node. Remember that the sum of all the traffic generated by the nodes should be equal to the sum of traffic received by the nodes. So introduce values, for example 7, 3 and 10 and 15, 5, 3, 7, for example 10. If not, it appears this error. To apply the gravity model, click on OK and introduce the correct value, 5. Click OK, and we can see the traffic matrix in the right section, and we can save this matrix or make other actions. Finally, we are going to create 5 matrices using the population distance traffic model. In the population distance model, the traffic from node I to node j is calculated following this expression of here, where level is a L by L matrix that allows introduce asymmetric traffics in the traffic generator. Pop I is the population of the node I, pop max is the maximum population, this ij is a matrix n by n with the distance between these nodes, and this max is the maximum distance. More information about this model and all its parameters is included in user's guide of Net2Plan. Returning Net2Plan, we focus on this section, traffic generator population distance traffic model. Before proceeding, a topology previously saved should be loaded by clicking Load from File button. If the topology is not loaded, it can be created in this panel, but Net2Plan contains several physical topologies as examples. In this case, we choose Top 7 Spain N2P file. Click on Open, and once loaded, node information is shown in the section named Topology Information. In this example, we can see 7 Spanish cities with its location, its coordinates, its population, and its level. These model parameters are included in the equation model and will remain by default. Here is the number of nodes, and here is level matrix. It's a L by L matrix, being L the number of levels or node types defined by the user. For instance, imagine we have a network with two types of nodes, clients and servers, and we want to create a traffic matrix for this network where clients don't send traffic to clients and servers don't send traffic to servers. This can be done defining two node levels in the network for separating client nodes and server nodes. Then we can use a level matrix with zeros in the diagonals, so the client-client traffic and server-server traffic is multiplied by 0 in the model. So in this case, for example, Madrid, Barcelona, and Valencia will be servers, for example, with the level 2, and the rest of cities will be clients. So the main diagonal will be 0, client to client traffic will be 0, and server to server traffic will be 0, and the traffic from clients to servers will be smaller than traffic from server to client. So the traffic from 1 to 2 will be 5, for example, and the traffic from 2 to 1 will be 50. We can enable this checkbox to make this traffic matrix with symmetric traffic, or make this later using this button. So after this, click on Apply Batch to generate matrices, number of matrices, in this case 5, and click OK. Click on yes, and again we can see matrices in the right section, and we can save them clicking Save All button. After generating traffic, there is usually a further level of shaping to make the matrix fit the situation modeled. By clicking on this drop-down list, different methods to normalization appear. 4 types of normalization methods are implemented: total, row, column, and normalized to maximum traffic that can be carried. The first adjusts the traffic matrix so that the total traffic offered to the network matches a user-defined value. We will apply to matrix 0, for example. Click on Apply. First select the total normalization, click on Apply, and introduce a total traffic in Erlang, for example 15 Erlangs. Click OK, and if we view the total, here is 15 Erlang. The second and the third modify the matrix so that a given row I or column j of the matrix assumes a vector defined by the user. Note that this means that the total traffic transmitted or received by node I or j is fixed to exactly this vector. We will apply to matrix 1, for example, a row-wise normalization, so select traffic matrix 1, select the row-wise normalization, click on Apply, and it appears this pop-up to introduce the total ingress traffic per node. For example, 5, 5, 5, and 10, 10, 7, and 7. And click on OK. And we can see here the total traffic by row fixed by the user. We are going to apply to traffic matrix 2 a column normalization. Select column-wise normalization, click on apply, and introduce the total egress traffic per node. For example, 7, 7, 8, 8, 10, and 10. Click on OK, and we can see these values here, the total traffic by column, and normalize to maximum traffic that can be carried. The target is to multiply the traffic matrix by a constant factor alpha so that the normalized matrix is the largest traffic matrix that can be carried by a particular network using the optimum routing without oversubscribing links. So select matrix 3, choose this method, normalize the maximum traffic, and click on apply this button. After this, it appears a pop-up window requiring choose a network topology to apply to calculate the optimum routing. Select the example 7 nodes and click on open. Then it appears another window to choose one form to calculate the traffic matrix. The users can choose between two forms of calculating this, an estimative method and an exact method. Estimative method, this method actually produces a matrix which is an upper bound to the maximum traffic that an optimal routing could carry. And the exact method solves the linear program that exactly computes the maximum factor alpha for which the traffic matrix still has a feasible routing in a network. The formulation is solved using the JOM library. The solver used and its DLL's location is obtained from the default values in the option menu. We click on File and Options. Here we can change the solver options, but we will remain by default. So click on Apply again. Select sample 7 nodes. Click on Open. And for this example, we select estimative method, estimative upper bound, and we can see here the normalized traffic matrix. And now we store this matrix. For example, clicking on Save this button, normalize traffic matrix 3. Click on Save. Now clear the panel. In some occasions, network design studies require a set of traffic matrices instead of a single one. For instance, when we need to produce a sequence of traffic matrices that reflect the forecasted traffic in following years according to a expected traffic rule. Also, it may be necessary to produce random variation of a single traffic matrix to test how the network performances vary if the traffic fluctuates. For this or other purpose, Net2Plan offers the following methods. In this part, the new matrices with a compound annual growth rate. So a sequence of traffic matrices is created representing ones for each of the incoming years, being the seminal matrix the traffic today. Each matrix is equal to the matrix of the previous year multiplied by a factor, where this factor is the compound annual growth rate. The uniform random variation, a set of matrices is created from a seminal one. For each new matrix, each coordinate is given by a sample of a uniform random variable with average x, where x is the coordinate value in the seminal matrix, and a user-defined maximum relative variation in the range 0, 1, and a Gaussian random variation. The set of matrices is created from a seminal one. For each new matrix, its coordinate is given by the sample of a Gaussian random variable with average x, where x is the coordinate value in the seminal matrix, and a user-defined coefficient of variation, quotient between standard deviation and average, and a user-defined maximum relative variation. This later value is used to truncate the sample. Finally, we are going to create several matrices from this seminal matrix using a Gaussian random variation. So we load a traffic matrix, normalize TM3 for example, click on open, and selecting this matrix, select a model, get Gaussian random variation for this example, and click on apply button. It appears a pop-up window requiring a coefficient of variation, a maximum relative variation, and the number of new matrices. These two values will remain by default, and the number of matrices, for example 5, and click on OK. We can see here the 5 matrices creates from this seminal one, following the Gaussian random variation model. More information about this tool can be found in user's guide visiting Net2Plan.com.